In this lecture, we're going to describe some basic mathematical approaches in dealing with data that are often described as nominal or ordinal. And the key approach here is to determine frequencies. In other words, counting the number of times a particular score occurs, especially if those scores align within unique categories. The symbol is an italicized lowercase f that is used to compute what are proportions or percentages. And we'll work through two examples of these calculations. So f refers to the frequency, which is an absolute number of cases that fit within a particular category. And n refers to the total number of cases in all the categories combined. So using some sample data here, examining university majors, the question here is what percentage of females are humanities graduates? And these are sample data obtained from, or hypothetical data obtained for different university majors in the province of Ontario, as an example. And so we first locate the major in question here, and those are humanities graduates, and we find that the total number of female graduates under the humanities major is 251,081. And we also make note of the total sample size of all female university graduates. And so in this particular case, the whole number, n, refers to the overall number of female graduates, in this case, over 1.9 million female graduates. The f, the frequency, or the total number of occurrences, refers to the number of female humanities graduates, which was going to the original question, and we then are prepared to calculate the percentage of the total female graduates from the humanities major by applying the equation. And so just by substituting the total number of female humanities graduates into the equation, as well as the total number of female graduates overall, and multiply that final number by 100%, we have a final value of 12.68%. The next question is slightly different. It's slightly different in that the question is asking for the proportion, not the percentage. And in this particular case, we're going to take a look at another group of individuals, and these are male education graduates. And so we locate the data in question here, and we locate the total number of males because we're asking the proportion of males that are education graduates and not the proportion of the total number of students that are male education graduates. So in this case, the whole number, the n, refers to the total number of male graduates, just over 1.6 million. The total frequency of the male education graduates is 120,000, and that was obtained from the raw data that were collected. And we just substitute the values into the equation, and we have a proportion of 0.074. Notice here, we do not convert this to a percentage, we do not multiply it by 100%. So in this situation, we have to make sure that the question is asking for a percentage or a proportion. The ratio is a similar approach here in that a ratio compares the relative sizes of different categories. So essentially comparing part to part or category to category. And it's just simply the quotient of the number of occurrences in one category divided by the number of occurrences in a second category of interest. Occurrences or cases, those terms are used interchangeably. So as an example, if we have a classroom of 42 students, of which 23 are females and 19 are males, we ask the question, what is the ratio of male to female students? And then what would we conclude from that calculation? So this will be a good time to pause the recording, go through the calculation, and generate the final answer, and then we'll check it here in a moment. Okay, restarting the video, we have our equation for the ratio of the number of males divided by the total number of females specific to our example. And so we just substitute the total number of males, 19, to the total number of females, 23. And we have a ratio of 0.83. This is the ratio of females to males and not the total percentage or the total proportion of males to the entire class. This is the ratio of males to females. And so we would conclude here that for every one female in this particular class, there are 0.83 males. Now, if we computed the reciprocal of this, so if we had the frequency of females, the frequency of males, and we flip these two numbers, we would conclude that there would be 1.21 females for every male. So the number of females, by looking at the raw data, clearly outnumber the males in this particular class, but the ratio provides us with a more precise indication numerically of the degree of difference between the two the two categories of students. And that leads to the next variable called a rate. And the rate refers to the number of actual occurrences in some phenomenon, of some area of interest, divided by the number of possible occurrences per some unit of time. And so this is really a comparison of the actual divided by the possible. And a rate is usually multiplied by a power of 10. Sometimes it's 1,000, sometimes it's 100,000 if we're dealing with epidemiological types of data, so examining large populations. And that aids with the interpretation of the data by eliminating a long string of decimal points. One example is computing the crude death rate, and that's the death rate from all causes. And so in order to calculate this rate, the number of deaths, the raw number, or the absolute number of deaths in a population, which are the actual occurrences, are divided by the total number of people within that population. So the possible number of deaths that can occur, which is the number of people in the population in a given year. And this value is often multiplied by 1,000. And this is a standard way of handling these types of data on a large scale. And so the equation to calculate the crude death rate is just simply the number of deaths divided by the total population, and it's multiplied by 1,000. This is not 100% that we saw a little bit earlier in our percentage calculation. So this is not a percentage per se, but a rate per 1,000 people. And so as an example, to calculate the crude death rate in Canada in 2012, we would need some data. And those data include the actual number of recorded deaths over 2012, which was 246,596. And at the time, the recorded total population was just under 35 million. And so to calculate the crude death rate, we would just simply substitute the relevant data into the equations and multiply by 1,000. And when we carry out these calculations, we come up with a value of 7.10. And we would finish a calculation such as this with a final concluding statement. That statement would indicate that there were 7.1 deaths per 1,000 persons in Canada in 2012. And the calculation of crude death rate in this manner now allows these data to be compared to the crude death rates in other countries, provided that those crude death rates in other countries were computed with the same equation. So this ends this lecture on our introduction to the management of rates and percentages.